Hi, my name is Miss Stacy Rodrigues, and today I'll be looking at project number 1, which deals with the circuit. Now I have here the things to make the circuit, which is the board, the battery, a switch, bulbs, and wires. Okay, now I will be making the circuit, and before I make it, I'm going to define the parallel circuit. A parallel circuit is one with several different paths for the electricity to travel. Now I'll be making the circuit. First, I have my switch. I'm placing the wires in. I'm now joining my wires. Tape it up for safety. Insert my bulbs. battery. Okay, and here we have our parallel circuit. Now for the lighting. Turn on the switch and the current flows. So a parallel circuit is one with several different paths for the electricity to travel. So there's more than one path. This is one path and this is another path. So that's the flow of electricity in several paths. Now I'll be labeling the parts. So here we have our battery. Bulb number 1, bulb number 2, our wire, switch, and this makes up the parallel circuit. Now I'll be conducting an experiment on these materials: nail, paper clip, glass, chalk, pencil, metal spoon. I'll be placing them in 2 categories, which involves
I'll finish the time next week.
Electrical conductors and electrical insulators. Now, electrical conductors are materials that allow the flow of electricity, and electrical insulators are materials that do not allow the flow of electricity. So I'm going to do an experiment on these materials here to see which one goes into the electrical conductors and which one go under electrical insulators. The first one we're going to try is the nail. So we're going to try to see if the nail can be classified as electrical conductors or electrical insulator. So I have the nail here. And it lights, so that means that the nail can be classified as an electrical conductor. Next, we'll use the paper clip. So I hold the wire at this end and touch it to the battery, and then see it will light. And it lights. So this too is an electrical conductor, which means it allows the current to flow through. So electrical conductor. Next, we'll use the glass. So hold the wire at one end and make sure it's touching. So glass does not allow the flow of electricity to pass through. So glass is an electrical insulator. Next, we'll use the chalk. Make sure it's touching. We turn on. Chalk do not allow the flow of electricity to pass through. So this too can be classified as an electrical insulator. Next, the pencil. Make sure it's touching there, and then we pencil does not allow the flow of electricity, so it is also classified as an electrical insulator. Last material, the spoon. As you can see, the bulb is lighting, which means the metal spoon allows the flow of electricity. And this can be classified as an electrical conductor. So under electrical conductor, we have the nail, the paper clip, the metal spoon, and under electrical insulator, we have glass, chalk, and a pencil. Now I'll define the term circuitry. Circuitry is a circuit or systems of circuits performing a particular function in an electronic device. Now I'll be explaining how the model and experiment can use to deliver the concept of circuitry to pupils. First of all, after displaying materials to be used for making of parallel circuit, pupils will be able to name the materials, the battery, the switch, wire, bulb, and so on, involving in making a parallel circuit. Secondly, after naming these materials, they will observe how we put together each part to make the circuit. While looking at this, they will get a better understanding of how the current flows through from the battery, through the wires, to the bulb and the switch. When pupils participate in an experiment or make a model, they tend to grasp the concept taught other than just reading or looking at pictures or videos. They will be able to relate and have a better understanding of what circuitry is about, given their first-hand experience. Now I'll justify why materials allow current to flow through while others don't. Now, given this experiment here, some materials allow the flow of electricity because they contain movable electronic charges. These materials are called conductors, electrical conductors. Example, the metal spoon, the nail. All conductors have electric charge. Why some materials do not allow the flow of electricity? Some materials do not allow the flow of electricity because they do not contain movable electronic charges. Example, the glass, chalk, wood. These materials are called electrical insulators. Now we're looking at if the removal of a bulb will affect the flow of current. Now, as you can see, the bulbs are lighting, everything is working here. So will the removal of a bulb affect the flow of current? No. The answer is no. The removal of a bulb will not affect the flow of current, given that their current in the circuit, the outer part of the circuit, in the other branches, there's still current. Now I'll show you. So we have current flowing here, and I'll remove this bulb. Let's switch it off and remove the bulb. So it's removed from here, and then we'll check. So it did not affect the removal of a bulb, did not affect the flow of current, or it does not affect the flow of current in a parallel circuit. Now for my final part, can any material in your home be used as a superconductor under other conditions? Yes. Now I have noticed that a coin from my home can be used as a conductor, as a superconductor, under the condition that it can work in a torchlight. If the torchlight, the battery, sometimes the batteries can be slack. So a coin can be used to put in to make the battery tighter for it to fit properly. So I'll just demonstrate this. And as you see, the current passes through. So a coin can be used at the bottom of a torchlight. Sometimes it's slack, so when you put them in, you can use 2 or more, depends on how tight you want it to be. And the current is going to flow through, and you're going to get the bulb to light. Thank you. Now this is my Now I've come to the conclusion of my assignment, which was based on parallel circuit, my definition, and here's the model of my parallel circuit and my experiment. Thank you. Thanks for watching.